Hello and welcome to the first video for 2024. Now today we will be making two Tall Toby practice models. Now these two models were suggested to me by a couple of great people. One of them is a bright young engineer called Sam Carter. There you go, Sam, here's your shout out, even if you didn't want one. And the other one is a new YouTuber that just started out. He's making videos with Libre and he's called Da Vinci. Let's go check these models out. Okay, so the first one is this egg cover cap. Now Sam suggested this one, and it's probably the hardest one of the practice models I've done so far, especially in Libre, and you will see why. But it's also full of traps, right? Like, look at these little details. The ribs and below the top surface, but the distance is not annotated. You've got these R question mark annotations here, which I hate when I see that. And as if that wasn't enough, you have this faint line here. Okay, now what this faint line means is that this surface, although it appears to be, you know, a continuous arc, it's not. It's actually two arcs, right? It's two arcs with two different radii, one here, one here. And if you look closely, you will see that this rendering of a window or whatever that is doesn't distort over that edge line. Now that instinctively tells me that these two arcs should be tangent, right? Although this is not mentioned anywhere in the drawing, at least the way I see it's not. So let's see how we can approach that. Okay, so we'll fire up a Libre. We will make a new part. We'll call it egg because we can. And let's start designing. Okay, so we will start. So yeah, let me show you first how I will start. I will start with this view here, okay, which is a 75 line here and a 125 line here. And then I need to make this first arc. Now this first arc, we've got its radius, okay? We have its radius, it's right here. It's 160 millimeters. The second one, we don't have its radius, but we know a couple of things. We know that it's tangent to the first one, and we know the center of that arc is exactly on that line, right? So that'll help. But in order to fully define this arc as well, we also need the center of this arc. Well, if you look really closely here, it seems that this arc ends perpendicularly to the front face. And indeed, if you also check this one out, you will see that we get confirmation that the center of this arc is indeed on the plane of that front face, right? And you can also see that the egg portion of it, without the pillar and the ribs, is a revolved feature, revolved and shelled. How can you tell it's shelled? Well, we get a 6 millimeter typical wall thickness here. That generally means it's shelled. So let's go and apply all of that. We will start the arc. We know that it's 160 millimeters. Okay, there's the center of the arc. We can either constrain it with a coincidence constraint to be on that line so that it ends up being on the front face, or, you know, I might have been designing like this and I couldn't see that center. So in a Libre, you can make an arc perpendicular to a line. And what that does is exactly the same thing. It puts the center of the arc on that line. Okay. So we've done that. Now let's create the tangent arc, put it all the way up there, okay? And we constrain it to be on that front, on that top line, and what do you know, this is fully constrained. Okay, now we will hit the space bar and we'll do a revolution. Oh, I get a problem detected. What problem do I get? It seems that I might have made this line twice. Yes, I actually did this front line twice somehow. I mean, okay. In any case, now I start the revolution, but which axis am I going to use? Well, of course I can use the z-axis, right, because of the way I drew the sketch. But look, I have my sketches toggled on up here. It's this little button, right? So when I get when I have my sketches toggled on in Alibre, I get additional options available to me, which I didn't even know until recently. One of them is I can use one of the lines without any other treatment or preparation as a revolution axis. Okay, so let's say that this is mid-plane 180 degrees, and we have the exact shape that we want. Now I'm gonna shell, and the wall thickness is 6 millimeters, and you will notice that I'm also removing this surface here. Okay, now why am I removing this front surface? And you will see that in a bit. Okay, so what feature do we design next? Well, next I will do this pillar here. Why? Well, I have these dimensions here, and then they're measured off the top of this pillar, plus the ribs also reference the pillar. Okay, this is the this rib here, and here you also see, right, this is this rib here. So generally speaking, it's better if you do this first. You can do the math, right, and extract the correct values, but there's no point. If you have direct values annotated here, just use them. Oh, and how do we create the pillar? Well, it's 15 millimeters over this top plane, and it goes all the way down to this circular bottom. So let's do that thing exactly. Now I will create a reference plane, and top tip here, when you're creating reference geometry, do not select the creation method first on your own, right? Do not do that, because 99% of the time Alibre is automatically going to select the correct one. So only if it doesn't, which is unlikely, should you choose it by yourself. And I say never do that. I mean, it just costs you a bit of time, right? If you want to save time, don't do that. By the way, let me show my planes as well. Okay, so this is the one that we just created, and we're going to create this pillar, which is 13 millimeters. It's in the middle, and it's 25 millimeters from this origin. Yep, I know. We need to go the other way. Extrude up to next surface, give it the correct direction, right? And we're done. And since I did that, I might as well do that hole that goes through it. So I just project in the top surface, and I pencil in the rough shape. Okay. Now, if I desperately wanted to have this fully defined, I would also add this horizontal constraint, which, by the way, because this is an arc, it makes sure that I'm still cutting well below the bottom surface, right? In case I didn't make it clear, I'm going for this internal cut right here, which ends up down here. Okay. Yep, so that's how I would do it. Now, the dimensions for this are annotated here. So, 75 millimeters from the top of this pillar is where this counter bore starts. And the through hole is a diameter of 12, and the counter bore is a diameter of 18. Okay, let's go apply all of that. So, the drawing tells me that this is 75. I need 12 here as a diameter, so 6 is a radius, and 18 as a diameter means that I need 9 millimeters of radius. And again, I'm just going to call it the Harald bar, right? Because the Harald menu, right? This context menu, I'm just going to call it the Harald menu because he showed us how to do it by how to bring it up by just hitting the space bar. And you can do all sorts of stuff, right? Look at that. This is so good that it's amazing. Anyway, so yeah, now I want a full cut, full 360 degree, and there we go. Now, if I take a look here, this is done. I mean, it's starting to take shape already, right? And I'll do the front face. Okay. I'm just going to sketch here on the front face. I need to project this in. Okay. And I know that this line needs to be, sorry. This line needs to be at the height. You know, my mouse doesn't want to work these days. I don't know what's going on. But anyway, this needs to be at a 45 millimeter height difference from the top of that pillar. So I do that, and then I just close the sketch with a center arc, and that's it. This is 6 millimeters thick, right? And look at this. I just extruded into the part, right? Going into the part. And as I hit OK, it will merge in such a way that this is not a straight line actually. It follows this surface, which is a compound surface because it's created by two different radii. One, this is the offset 160 millimeter radii, and the other one is this 75 millimeter radius around which I revolved. So this now, as I push it and extrude it into the material, it creates this edge which follows the compound surface perfectly. If I had not shelled and removed this front face and did this opening by a cut, I would have gotten a straight line here, right? And this would have been wrong. Funnily enough, I did try it, and the mass is still within tolerance. So in the context of Too Tall Toby's competition, this could have worked, but you know, this is the correct way to do it. So now we're going to tackle this rib here. Okay. Now, how are you going to get a closed sketch? You saw I'm drawing on the YZ plane, so I'm going to sketch it and then extrude it mid-plane. But how are you going to get a closed sketch? I mean, you need to project in the section of this surface to the sketch plane, and you can't do that, right? You can't do that in a Libre. Well, you can. I mean, you can do pretty much anything in a Libre. So what you do is you do a precise section view. For the slicing plane, you select the plane that you're going to sketch on, right? And these arrows come up. These arrows show you the side of the material that is going to be left after the section, okay? Yeah, after you do this precise section view, you start sketching, okay? And before you do anything else, look, you can select the cut faces for projection, which is amazing, actually, right? So, but the problem is you cannot maintain associativity, right, to a face that has been created by a precise section view. So you bring it in, but then you need to lock everything manually by hand. Okay, so that's the problem there. Okay, let's lock everything that we're going to use at least. And I think we are good to go. Sometimes, especially with arcs, you also need to lock the endpoints, but we'll see how that goes. So I have this projected in now, which is the section view of a surface to my sketch plane. I have a projection for that. Now I can start drawing. So a bit of a straight line and then a tangent arc, which I will just click here so that I make coincident, but you know, nothing else. And let's start now putting dimensions in, right? So we know that this arc is 190 millimeters in radius, and I also know that the straight part of this rib ends 30 millimeters from the center axis of that pillar. Okay. What else do we have? Right. We also have this dimension here, the 5 millimeters, that tells us that this rib here starts 5 millimeters below the top surface of this pillar. Okay, so let's go plug all of that in. So this is 190 millimeters. Okay. Oh, I hadn't made that tangent for some reason. Okay. My mouse doesn't want to cooperate with me today. So this is 5 millimeters, right, from the top of that surface. And I need 30 millimeters to the axis of this pillar, but look, I can dimension to it. Now, here's another really cool bit of trivia about Alibre, which again, I didn't know up until a couple of weeks ago, basically. When you have your sketches showing, I never had my sketches showing. I didn't like the visual impact of it. But look, when you have your sketches showing, you can do this. You open this project to sketch, clicking here or shortcut, and then you can select a single sketch entity from a previous sketch and bring it in, right? A single sketch entity or a few of them, right? And you can create them and bring them in a newer sketch. So this is what I'm going to do. I'm going to create a reference figure maintaining an association to it. And 30 millimeters. Okay, so that's good. And what else do I... right, yeah, you see now, this is moving. Right, that's why it doesn't... okay, let me... When you're... There you go, now it's fully defined. So when you're projecting stuff, right, and you're not maintaining association to it, it's better to select edges instead of faces to project, right? Anyway, so I did the hard part. Now I need to trace it around. But remember, this is a rib, okay? So this is a standard tip. Every time you create a rib, especially if you're going to mid-plane extruded or something, you always want to design it going into the material, right? Because imagine if we left it, if we close the sketch like that, as soon as we extrude in mid-plane, we will create a face that is tangent to that cylinder, right? It doesn't connect to it. Now you will see that the way we'll do it, it will hug the outer surface of this cylinder. Okay, so let's close this sketch. This arc, okay, I can make this into a geometry entity because I need all of it, but I need to create a new center arc here, right? Because I don't need all of that. I just need up to this point. So now actually I've got an airtight sketch and it's based on the section of a surface to a sketch plane, and that's amazing, you know, to me at least, if you ask me, it's a really powerful tool. Okay, so I did that. It's not associative, so I don't need that view anymore. And let's go make the other rib as well. Now, here's a huge trap for the other rib. We know, the way it's annotated, we know that that rib ends 30 millimeters, right, from the center axis of that pillar. In other words, this rib, the end of that rib, lives at the precise point where the other one starts curving down. Okay, but if we let's look at it at this view, right? If we create the sketch here, right, and extrude this way, what we're going to end up with is an extrusion that is going to be like this. Okay, you see this? You see that the extrusion is going to be flying off this sidewall, right? We don't want that. So what we need to do is we need to sketch on the inside side, right, of that rib, and then extrude into the material, right? Plus, I also see here that the ribs are 4 millimeters thick. And let's go back and check that we have actually made it 4, and it's 6. There you go. Got that error. Okay, so back to that rib. It ends 30 millimeters from the center of this pillar. That pillar lives 25 millimeters from the front face. That means that the rib ends 55. So that rib lives 55 millimeters from the front face. That's where it ends. Okay, but I need to know where it starts. Well, I know it's 4 millimeters thick, so it starts 51 millimeters from the front face. So let's go do that. 51, and no, I need that in the reverse. Okay, so that's where I'm going to sketch, but again, I need the section. I need to project, right, pieces of the section of this compound surface to the sketch plane. So how do we do that? Well, we create a precise view. I want this piece to remain, and we're good to go. And now I will sketch here. This time, the only thing I need to project is this arc, right? Because this is symmetrical either side. And you will see how I'll make that. So, I didn't show you guys the dimensions. So let's get the rough shape penciled in, and I'll show you the dimensions afterwards. So this is tangent to that. Okay, so section BB is this one, right? So let's see. It tells us that first of all it's symmetric, right? This is 60 millimeters, so that means that this is 60 millimeters as well. 15 millimeter flat, and a 10 millimeter from this side here, from this top face, but we already knew that because we know that this is tangent to the other rib there, so I'm not even going to use that. What I'm going to do is I'm going to project in this edge, again lock it, and let's start putting the dimensions in. So this is 60, this is symmetric, which means that it's equal. And let's make these two horizontal. This will be enough. You'll see why. Because we know that this linear segment needs to be symmetric around this point. So I will use my midpoint constraint with 3 points. This is now constrained this point to be on the perpendicular bisector of this line segment. Okay, so let's give this a length of 50, and let's say that this is collinear to here, and look at that, right? Fully defined. So now I just need to close the sketch with a center arc from this point to this point, and I'm ready to extrude. I'm going to extrude into my material for 4 millimeters. I don't even need to have this anymore. And my part is done, guys. That's it. Let me turn off my planes and my sketches so we can get the pure shape going here. Look, you see this rendered light, how it doesn't distort around that edge. So we got that as well. You can, I don't know if you can make it up in your screen in YouTube. There's a second blue light that doesn't distort over that edge either. So we have that. We've got the ribs being tangent. Everything looks great. So this should be 251 grams as per the legend. Before we can get an answer though, we need to give it a material. This is supposed to be made out of ABS. If you don't give it a material, you'll get back a ridiculous number. And there you go. Actually this, 0.2511 kilograms, that's 251.1 grams. This had a tolerance of plus or minus 1 gram, so we're bang on essentially. And this is correct. So that's how you do this, right? A lot of traps in this one drawing. This in a speed modeling situation would have been a hard one, I think is the technical term. Okay. So let's go to the second one. So this practice model, Total Toby released a video doing this in doing this model in Onshape, right? And I would handle the symmetry in this model slightly differently. Okay, so you have symmetry here and you have symmetry here, right? So it's a highly symmetrical model. Other than that, it's a pretty simple one, so it's a good example, I think, right? You have this cam lobe shape, I'm gonna call it. It just has a hole in it. You cut a bit of a slant to the outer faces. Then you have this reinforcing rib here with a couple of cutouts, and that's it basically. Oh, plus you have these things here. Right, another interesting approach. It seems that everybody is doing it in a different way. I will do it in a different way than Da Vinci did it, and Da Vinci did it in a different way than Toby did it. Right. So let's jump in and discuss everything as we go along. So I will start with this cam lobe shape with a hole in it, right? And you can clearly see that this is extruded for 7 inches, right? As you can see here. And it is very well defined in this view. Okay. So yeah, let's start the part first. And you know, generally important. And as I say that, now this is in an IPS system, so inches, pounds for the mass, and seconds, yeah, sure. And it's a steel part. So let's go do all of that. For the speed modeling competition, I have a template ready made like that. But if you wanna change it in a file, you go to, let me do that again. You go to Properties, Units. Okay, you change the units, you change the mass, and you just hit apply. Okay, so let's start drawing. I will start drawing in the YZ plane. To me, it doesn't matter where you start drawing, right? Unless you need a very specific orientation in space, which you don't really. I don't in this part. So let's say that this is 1.5 radius, okay. This is a 1-inch radius, and let's connect it with lines. Now I want to make the center points horizontal to the origin of my sketch. I also want to make them symmetric about my origin using the midpoint constraint with 3 points. Then I need to make everything tangent here. Okay. Yep. Okay, didn't like that last tangent constraint, so I think I'll just give it a yes. There you go. Horizontal constraint. So 1 inch, 1.5 inch. The last dimension I need is that these two centers are 3 inches apart. So I've got my Kamloob shape, and I also need a 1.5 inch hole in it. Okay. So what am I going to do with this now? Am I going to extrude it, in an offset manner? Or do I need to create another plane? Alibre doesn't currently have offset extrude. No, what I'm going to do is I'm going to mid-plane extrude it for 7 inches. That's it, right? So that's how I'm going to handle that. This will not be mirrored. This feature does not need to be mirrored, right? Then I will do the cutout that will create this rib. Okay, section AA here, right? There it is. Shows us everything we need to know about how that rib is formed. The section goes through the cutting, the opening. For now, I want to create it as a continuous piece because I want to empty the insides out. Okay, so what do we have? We've got one arc, right? We've got one arc at 1 inch, and we have another arc at 1 inch 0.25. So you need to look in the slice section and in this initial view to get the full story. Plus, there are 130 degrees missing from a full circle here. Okay, so let's go do all that. So, by the way, let's go to view. I need to have my sketches toggled on and my planes. Okay, so I'm going to sketch on the YZ plane again. I'm going to project everything in and then turn this back into a reference geometry. And now I'm going to start making my my center arcs. Okay, let's get another one going. One. Now I'm going to plug the ends and perpendicular constraint, line to arc. Okay, it seems this is a pretty unique thing to Alibre. I want to make these points. My mouse is not working very well. Okay, I seem to be having a bit of trouble here for some reason with the vertical constraint. Okay, but I can always make a line here and call that vertical, right? And in any case, we know that this has 130 degrees here. So I've got this fully defined now. And I also have the outer shape as a geometry entity, right? Projected in as geometry. So if I do an extrude cut mid-plane, okay, I don't want the full 7 inches. How much do I want? Let's check the drawing. I need the cut to stop 1 inch before the end, either side. So 2 inches. I need to leave 2 inches from those 7. So I need 5 inches of cut. Okay. Look, I mean, it's starting to take shape. So up to extrusion 2, I wouldn't mirror anything, right? It'll be like that. I just leave it like that. Now, we'll start working on one side and then mirror everything at the end. So, go to the ZX plane, right? I'm going to project this in as a reference. I'm going to make a slant line. Let's put the 6 degrees in and single line, right? So I exit the sketch, I ignore this warning, thin extrude through all. I just need a large enough number to take everything off the side. I'm good to go. Okay. Now I need to make the opening in this rib. Well, I'll design on this surface. I'll just bring the entire surface in because that's easier than playing with selection. So how would I do it now? I'll just make the two lines here. Okay. Then I'll make the lines perpendicular to the arcs. Okay. I will make these vertical. I will give the 1.5 inches dimension here. Where does that come from? It comes from this section view here. And you need to pay attention because the 1.5 inches is measured off of the outer points, not the inner ones, right? That would give you a different angle here. And now that I have that fully defined, I just close the sketch with the appropriate center arcs and extrude cut for 2 inches. There you go. And I will now make this little nub or tab or whatever here. So again, I will draw on the XZ plane, ZX plane, whatever. I will project this in, and let's take a look at the drawing. This is what I'm doing now. Okay. It goes on for 1.375. Then you have an arc here. Okay. Then that arc is clearly tangent. Well, it's clearly tangent to that front. Why Adobe? Why? It's clearly tangent to that other line. And yeah, and then the front just follows this curvature, right? You can also see it very clearly here. And that back radius is R.375. So let's go do all that now. So I'm just going to make a line, 375. There you go. And I'll make my arc. Okay. Now, that arc starts off perpendicularly to that face. That means the center is on this line. And it's tangent to the other line that goes off. And that means that the center is horizontal to the end point. Okay. Let's make this horizontal again. And let's give this the radius, which will also determine the thickness of our tab here. The Herald menu, and I will select, let me see it a bit more clearly. I will select this line from the sketch, right, because I've got my sketches toggled on to revolve. Actually, I could do it like, yeah. You can either say that this will be 180 degrees as a midplane, or you can just, you know, leave it as is and do the full revolve. You can still leave it like that. But this doesn't follow this face. Okay, so how do you do that? Well, then you do another sketch in here. You project this in. And then you draw a rectangle that's big enough. I'm not even going to dimension that. That's good enough for me. And then I'll do a revolve cut. Okay. And what's going to be the axis of my revolve cut? Well, I want it to follow along this surface. So this is going to be the axis of my cut. I will need that to be a mid-plane cut. And I'll need that to be big enough to clear my front face, so 60 degrees should be enough. Look at that. Huh? Perfect. And so we're good to go, right? Now I'm going to mirror everything. So up to extrusion 2, I don't need a mirror, so I'm mirroring everything else. Mirror plane is this. Good. And then I'll add the fillets. And the reason I'm doing the fillets at the end is sometimes fillets don't like mirrors. Libre seems to struggle a bit more than Fusion or SolidWorks, but there you go. And yep, and that's it. By the way, the fillet value is specified here. Okay, and that's it. That's it, guys. This is done. Okay, let me hide my sketches and my planes so we can see the pure geometry. There you go. Nice looking part, if I may say so. But you know, Toby's practice models are always nice. Okay, cool. So let's check the mass. Before we do that, we need to assign it a value. Okay, assign it a material rather. And if we calculate it, the mass is 5.723 pounds, right? So this is the correct answer for this part, and that's how I would do it, and that's how I would handle the symmetry in this part. Of course, in a speed modeling situation, pressure will always get to you. So in a similar part, in a speed modeling situation, I might handle the part differently, but with a clear head, I consider this to be the more efficient way to do it, right? So don't be mirroring things that you don't need to be mirroring. That's basically it. So that's it for today, guys. If you want more videos like that, hit the subscribe button or go check out another video on my channel. They're all pretty similar. And if you liked it, hit the like button. And if you disliked it, hit the dislike button, because I still need to know. And I hope I see you in the next one.